Hey shawty, it's your birthday. We gon' party like it's your birthday. But we gonna sit. It's your birthday, and we don't give a fuck. It's cause it's your birthday. You can find me in the club. What's up, everyone? It's your boy JOSHABRAHAM. Why did I sing a 50 Cent song in the beginning? I don't know. But you know what? I really want to know the lyrics of what was that song? What was that song? Go, 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 sorry, it's your birthday. Find me in the club. Is it in the club? No, I don't think so. That's something else. Oh, yeah, yeah, it's in the club. Go, 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 sorry, it's your birthday. We go. No. Why would you do this? Reject. We gonna sip Bacardi like this should. Oh, it was Bacardi. I thought it was something like Bugatti. Bugatti. No, it's Bacardi. It's your birthday, and you know we don't give a fuck. It's not your birthday. What? I thought it was your birthday. You can find me in the club, bottle full of bub. Look, Miami, I got the X. If you into taking drugs, I'm into having sex. I ain't making love. I ain't into making love. So come on, give me a hug if you into getting rubbed. So you can find me in the club, bottle full of bub. Look, Miami, I got X. If you into taking drugs, I'm into having sex. I ain't making love. So come on, give me a hug if you're getting rubbed. That's some bangers. Not gonna lie, I did not expect it to be Bacardi. I thought it was Bugatti or something. But hey, the more we know. Oh wait, it was. I should be preparing for analytical chemistry. You're goddamn right. And I don't know from last stream if I said something like I'll be streaming in like 1 hour. Apologies, gang. I had some stuff going on. I had some weird stuff going on. But back. Okay, that's not what I meant. It's not what I meant. God damn. God damn it. God damn it. Gosh darn it. Gosh darn it. Go. Oh, come on. Oh, there it is. There it is. There's my. Somebody just wrote. Somebody just wrote the used the chat. Emmanuel Brewer. Hi. Hello. Hello, Emmanuel Brewer. How is it? How is brewing going? Oh, it's 11%. Okay, okay. I'm sorry. I'm sorry. I'm sorry. I'm sorry. I'm sorry. I said I'm sorry. Okay. I did not mean to let you be like this. Good. Oh, nice to hear that. I'm also doing pretty good, but I got an exam coming up, and I gotta prepare. I gotta prepare. I gotta prepare. I gotta prepare for that exam. I gotta. Don't mind that. Be right. Be right. Be right. Be right. BB. Oh, okay, okay. I gotta prepare. That's what I was going for. I had to prepare for my analytical lab exam. Vibe, why so late? Yo, I'm sorry, gang. I had some really important stuff. Okay, I can't do a Trump impression, but I had some I had some really important stuff going on. I was cooking. I was having some loud burp. I had a cousin who could do burps on command. Like India's got latent moment. Oh, I've seen that comedian. I've seen that person. I'm not gonna lie, it's pretty good Trump impression, but I don't think it gets close as mine though. My Trump impression is like, China, China, very good. I'm not very Chinese. Oh, no. Oh, that was that. I don't know. I feel really bad for doing that. I'm 9. Oh, I've been through a lot. Damn. Like how much a lot we talking? Like you've been bullied in school. Like you had to sell lemonade type shit. Like some. Oh, I don't want to say that. But yeah, like what you been through? What, gang? Like some hardcore shit. Like yes. Oh shit. Like you abused someone. Someone can try to kill you. What's going on? Bro was rejected a PS5 when he was 5. Yo, that's tough. Okay, if you get rejected, if you got rejected by a PS5 when you was 5, damn, that's like up here. That's tough. That's just like going to jail, prison, surviving the prison for 2 years, straight up. No Diddy, no Diddy. But hey, yeah, damn. Oh, damn. You are you really sad or you're just expressing in that way? Please don't tell me you're sad. But I don't understand what is this tough shit that you've been through? What happened? Did you get punched in the face? What happened? Cause I got bullied when I was a kid. Oh, go get me a lemonade, kid. Yo, we don't gotta be rude to people, okay? We don't gotta be like that. I'm sad inside, no emo. Oh, it's like saying no. Okay, I guess no emo. Well, what made you feel bad? What? What did you go through? Yeah, I was bullied as a kid. Well, how was I bullied? I don't remember exactly, but there was this big dude, big kid. He might be like 2 years older. It's a long story. Oh, okay. Damn. Okay. I see. I see. But what is this story related to? Is it like school? I don't know. Home, internet. I know next. Hello, I'm back. Yo, you made it. You made it. I remember you coming to the last stream and it was like, can I get the hug before I go? I will sub. Well, I don't know if I could hug because I don't know you. But hey, virtual hug, I guess. Just remember, it's all gonna be alright, okay? It's all gonna be alright. Breakup, 1 a.m. talks. Oh, it's 1 a.m., okay. But like I was saying, I was bullied when I was a kid. Thanks. Bullied when I was a kid, and what was I bullied for? I don't remember, but it was in the bus. I will remember this. Oh, you should. What was I saying? It was like those bus rides back home from school to back home. What the weather there? It's like 32 degrees. And this person, what did this person do? This kid, I think he tried to get into my backpack, took a notebook, took a page. I was like, yo, stop, dog. This guy just, I don't know, he punched me, but just got aggressive. I was like, okay, I know one thing, that I cannot overpower this person, this kid. What shall I do? Bullied for accident, maybe. But I remember what I did. I stayed away from this kid. That's what I did. And hey, it worked. Because that I did not see that later. Because if I did, oh, he's focus in your studies. You're right, gang. Damn. Respect. Yes. Chloride containing solution in the redox is a redox titration where you use potassium permanganate as a strong oxidizing agent to quantify the iron in your sample. This experiment. See you. I'll remember all of this. You'll see I'll be back. Oh, yeah, of course, gang. Understandable. The fact that you checked out the stream. Respect. But potassium permanganate is not the primary standard. Yeah. Reaction heat requirement. The reaction between permanganate and oxalate is slow at room temperature. To ensure the reaction proceeds at memorable rate. Oh, what the okay, I understand. 1 hour. 45 minutes. 45 minutes. 30 minutes. 15 minutes. 20 minutes. You don't need an external indicator for this step. Manganate ion itself is a deep purple color and the first persistent faint pink color lasting 30 seconds. indicates the endpoint where a tiny excess of MnO4 is present. Okay, I need to understand what I need to understand what results in this faint, persistent pink color. Flexing watch. Yeah, I know. Whoa. Whoa. I'll be back with something, you'll see. I'm leaving now. Yo, respect. About the flexing watch thing. You make me say this. So this is the watch SC2, which is like, I've been using this for like 4 years. 4 years, and I gotta say, shittiest watch out there. I don't usually track the whole heart rate, everything. I don't use it. One of my main use case scenario is setting timers, alarms, etc. And when I'm outside, I use this phone. It's like an older phone, and the watch does not connect to an older phone because it's an older version. You stupid. You stupid. I cannot use this thing when I'm outside. In your next stream, chant my name. My nickname is Mr. Yin Yang. You know what? You should type in that name when you come into the stream. I might just connect the dots. Okay, bro, study. Hey, sorry for disturbing. Nah, you gotta listen more. So my plan, if when I get some money, my plan is to wait. I'll show you. God damn it. HK49 Pro smartwatch. Yeah. Not this one. Okay, see you in one day, cracker. Let's go. Oh, come on. You gotta be kidding me. HK49 Pro smartwatch. Okay, basically it's a watch that looks like, never tell your plans to anybody. Okay, so basically it's like a Apple Watch clone, but it runs some sort of Android OS. So I can tinker with it. And I'm planning to do something on my own when I get a cheap knockoff watch from China, straight from China. Because this thing does not allow you to change anything. When do you sleep, bro? I should sleep in like 2 hours. Okay, study. Oh. Yup. So I should make a video on the whole the watch being useless. It's 1:30 here. Yeah, you should not be up till that late. Do you have classes or anything, Wybov, tomorrow? Because if you have, you gotta wake up early, right? I just got this exam coming up. And the reaction between permanganate and oxalate is slow at room temperature. To ensure the reaction proceeds with measurable rate, the solution must be heated. Self-indicating sample preparation and production. The iron in your sample may not all be Fe2 plus state, so some might be Fe3 plus due to oxidation by oxygen in the air. 5 hours of sleep from the past 8 days. Again, that's retarded. I am superhuman. No. No, you are destroying yourself, human. Reduction step: to ensure you are measuring the total iron content, you add 3 grams of sodium metabisulfate to the acidified sample. To ensure you're measuring total... Shut the fuck up. Who is that? Whoa! Why is it not working properly? Iron in your sample, okay. To ensure you're measuring total iron content, you add 3 grams of sodium metabisulfite to the acidified sample. Refluxing: this mixture was boiled until the volume was reduced to approximately 100 milliliters. This ensures that all iron species are fully reduced to Fe2+, at which point the solution becomes almost colorless. Colorless. The mixture was boiled until the volume was reduced to approximately 100 milliliters. The mixture is boiled until the volume is reduced. All iron species are reduced to Fe2+, at which point the solution almost becomes colorless. Okay. Standardization of potassium permanganate solution was carried out by using sodium oxalate as a primary standard. Approximately of sodium oxalate was accurately weighed and transferred into a separate 400 milliliters titration flask. About 200 milliliters of deionized water and 10 milliliters of sulfuric acid was added to each flask. The solution was heated to 75 to 85 degrees Celsius and titrated while hot with potassium permanganate solution until a faint pink color persisted for at least 30 seconds. The temperature was maintained about 75 degrees Celsius during titration to ensure accurate results. For the determination of Fe2+ ions, 25 milliliters of a sample solution was transferred from a 250 milliliter volumetric flask into a titration flask. Approximately 200 milliliters of deionized water and 10 milliliters of hydrochloric acid were added. Sodium metabisulfate 3 grams was added to reduce all iron species to Fe2+. Okay. The mixture was heated until the reflux in a fume hood until the mixture was heated until not until, goddamn. The mixture was heated under reflux in a fume hood until the volume was reduced to approximately 100 milliliters, ensuring complete reduction of the iron species. After cooling, deionized water was added to adjust the volume to 400 milliliters, and 10 milliliters of Zimmermann-Reinhardt reagent was added. The solution was then titrated with standardized potassium permanganate solution until a persistent faint pink color remained for more than 30 seconds. The procedure was repeated for 3 measurements. Okay. Why is it not copying? Okay. Why is it... There's something wrong with the mouse. Just a minute. I'm doing everything except studying. Yep. I do feel like it. 10 minutes? Okay. Don't gotta do all that. SVGS. I don't know what that is, gang. I really don't. Did I ask my question? No. Could you explain how exactly is this self-indication working on a molecule scale? How is oxidizing the Fe? Transitions occurring on a molecular scale are driven by movements of electrons. First, it is important to clarify is to use to reduce. Okay, I thought about it. I was like, okay, Fe3 plus to Fe2 plus could be reduction, but hey, this here it's addition of an electron, so it could be oxidation. No, got it wrong. Here's the molecular breakdown of self-indication and reaction process. Molecular scale, how self-indication works. In most titration, you need an external indicator serve as its own indicator because of the dramatic change in oxidation state of manganese. The purple state, the manganese ion contains manganese in +7 oxidation state in a molecular level. The way the electrons are arranged on that oh fuck, 15 minutes, come on. Manganese atom allows it to absorb specific wavelengths of visible light, resulting in a deep purple color. The reaction phase, as you add purple KMnO4 to the flask containing Fe2 plus and Zimmermann-Reinhardt reagent, a redox reaction occurs instantly. The MnO4 ion steals electrons from 5 Fe2 plus. And Zimmermann-Reinhardt, wait. As you add purple KMnO4 to a flask containing Fe2 plus and the Zimmermann-Reinhardt reagent, redox reaction occurs instantly. The MnO4 ion steals electron from the Fe2 plus. The colorless state, once it gains these electrons, the manganese is reduced to +2 oxidation state. Unlike the purple +7 and the Mn2 plus ion does not absorb visible light significantly in a dilute solution, so it appears colorless. The endpoint, through the titration, the purple drop disappears as soon as they hit the solution because they are converted into colorless Mn2 plus. Once every Fe2 plus ions have been reacted with, the next drop of KMnO4 is now more electrons to steal. These MnO4 minus ions remain in the purple +7 state, and their presence in a large volume of water creates the persistent faint pink color. Ooh, so it's the MnO4 minus that existing, that a very low amount of MnO4 minus existing shows as a pink color. Okay, what about the reagent? And the Zimmermann, the role of sodium metabisulfate. As noted, sodium metabisulfate is a reducing agent, meaning it provides the electrons necessary to convert Fe3 plus back into Fe2 plus. Why it is needed? Iron 3 is not entirely stable in an aqueous solution. It naturally reacts with oxygen from air, which steals its electrons and it converts it to Fe3 plus. It is not entirely stable in aqueous solution. It naturally reacts with oxygen from the air, which steals its electron and converts it into Fe3+. Since your titration formula specifically requires Fe2+, any Fe3+ in your sample would go unmeasured, leading to an incorrect result. When you add 3 grams of Na2SO5 to the acidified sample and boil it, the metabisulfate reacts to release sulfur-based species that acts as an electron donor. These species donate electrons to the Fe3+ ions. On a molecular level, the iron atom regains an electron, moving from +3 state back to its +2 state. Visual confirmation. You can actually see this happening. Fe3+ ions often give the solution a yellow or brownish tint. As the reduction proceeds during the boiling/reflux phase, the solution becomes almost colorless, confirming that the iron is now Fe2+ form and ready to be titrated. Okay. Ready to be titrated, okay. Summary of the redox flow. Reduction step. Na2S2O5 gives electrons to Fe3+, creates Fe2+, colorless. Oh, why can't I say it? Why can't I say the word colorless? Titration. Purple takes electrons from Fe2+, creates Mn2+, colorless. Endpoint Fe2+ left, no Fe2+ left to give electrons. MnO4- remains in solution. Yeah, I didn't fully get what. Ten minutes? What? Oh, that's so weird. So 9 minutes to get to the 30 minutes. Oh, it's just past 20. Okay. Watson. No. Center. The Franz Crick Institute. Zimmermann-Reinhardt reagent is an essential additive to your iron titration because your sample contains chloride from the hydrochloric acid and used for preparation step. According to resources and procedural context, the reagent performs two primary functions to ensure the results are both accurate and easy to use, preventing the chloride error. Potassium permanganate is an extremely strong oxidizing agent in a solution containing Cl- ions. The permanganate would not only oxidize your target iron, but would also start attacking the chloride ions, converting them into chlorine gas. The problem: if this happens, you would end up using a higher volume of titrant than the necessary, leading to an incorrectly high calculation of iron content. The Zimmermann-Reinhardt contains components that specifically inhibit the oxidation of chloride, ensuring that every drop of KMnO4 you add from the burette reacts only with Fe2 plus ions. Sharpening the endpoint visibility. During the titration, the iron 2 in your flask is oxidized to iron 3, Fe3 plus. The problem: in the presence of chloride, Fe3 plus creates a yellow or brownish tint in your solution. This yellow color is a major issue where it masks the faint pink color of this endpoint, making it very difficult to tell exactly where the reaction is finished. The Zimmermann-Reinhardt reaction acts as a bleaching agent for the iron. It reacts with the Fe3 plus acid produced, forming a colorless complex. This keeps the solution perfectly clear throughout the titration, allowing a very first permanent trace of pink from the excess permanganate to a clearly visible. Chemical details, independent verification recommended. Composition. The reagent is a mixture of manganese 2-sulfate sulfuric acid and phosphoric acid. Manganese 2-sulfate provides a high concentration of Mn2 plus ions, which lowers the reduction potential of the permanganate and kinetically prevents the oxidation of chloride. Phosphoric acid. This is a specific ingredient that complexes the yellow Fe3 plus ions to keep the solution colorless. Sulfuric acid provides the necessary H3O plus protons for the permanganate to be reduced correctly to Mn2 plus rather than forming brown MnO2 precipitates. But again, here, if it forms this complex, then here, if it forms this complex, then that's gonna be lost iron. Like, it won't be considered or be part of titration, thus giving us how is this complex reduced back to its what? It is understandable the term bleaching agent might cause concern regarding the accuracy of the result. The complexation of iron by Zimmermann-Reinhardt reagent does not result in lost iron or false result because analyte Fe2 plus your titration is specifically measuring the amount of iron, 2 ions in the flask, of reaction. When you add purple MnO4 titrant, it reacts with the Fe2 plus. The iron loses an electron to manganese, transforms into Fe3. The timing of complex. The Zimmermann-Reinhardt reagent only acts with Fe3 plus after it has already been produced by the titration reaction, because the iron has already accounted for a KMnO4 volume by reacting as Fe2 plus. Tying it up in the complex after reaction is complete does not change the amount of titrant you use to reach that point. Why the complex doesn't need to be reduced. Why the complex doesn't need to be reduced. You asked how this complex is reduced. The answer is it is not reduced back into a titration. Doesn't need to be. The purpose of the titration is to find out how much Fe2 plus was there to start. Once that Fe2 plus is converted to Fe3 plus, its job in the titration is finished. The color problem with Zimmerman-Reinhardt, the accumulating Fe3 plus would turn up the solution yellow, making it impossible to see the faint pink endpoint conversion. The solution, by locking that Fe3 plus onto a colorless complex, the Zimmerman-Reinhardt simply keeps the background of your flask clear so you can keep... Okay. So, sodium oxalate, water plus water titrant. $30 already. Okay, now just summarize the whole experiment from the start, including explaining the parts where I asked further in a way that oh, come on. The fuck you mean you got a problem? Do we got a problem? to prepare you for your oral exam. Okay. Here's a comprehensive summary of the determination. The goal of the experiment is to determine the mass of Fe2 plus in the sample containing chloride ions using redox titration with potassium permanganate. The fundamental reaction is a 1:5 stoichiometry standardization calibration of the ruler. Since KMnO4 is not a primary standard, you must determine its exact concentration using sodium oxalate. The heat requirement. This reaction is slow at room temperature. You must heat the solution to a 75 to 80 degrees Celsius and titrate while hot to ensure the reaction proceeds quickly enough for an accurate measurement. Self-indication. On a molecular level, the MnO4 minus ion plus 7 oxidation state is a deep purple. 7 conversion history. During titration it is reduced to Mn2 plus. This colorless which is colorless 7, the endpoint is reached when a tiny excess of MnO4 minus remains, turning the solution persistent faint pink. Sample preparation. The reduction step. Iron in a sample can naturally oxidize from Fe2 plus to Fe3 plus when exposed to air. Sodium metabisulfate added 3 grams of this reducing agent to ensure all the iron species are converted back to Fe2 plus. Molecular action. The metabisulfate donates electrons to an Fe3 plus, reducing it to Fe2 plus. This ensures 100% of the iron in the sample is ready to react with KMnO4. Boiling. The solution is boiled until the volume reaches 100 milliliters to ensure the reduction is complete, at which point all solution becomes almost colorless. It was already colorless. It was already colorless. Oh, why can't I say it fast? Why can't I say the word fast? Colorless. It is already colorless. It's already colorless. It's already colorless. It's already colorless. It's gonna be colorless. It will be colorless. Almost colorless. Colorful, colorless, colorman, coloring, color. Zimmermann-Reinhardt reagent. Because your sample contains chloride from the HCl, this reagent is mandatory. It performs 2 vital functions: preventing the chloride error. KMnO4 is strong and that it could oxidize Cl- into chlorine gas, which would consume extra titration and lead to an incorrectly high iron result. The Zimmermann reagent inhibits this side reaction. Conversion history. Complexing iron 3. As the titration proceeds, Fe3 plus is produced, which has a yellow-brown color that would mask the pink endpoint. The Zimmermann-Reinhardt reagent forms a colorless complex with the Fe3 plus, keeping the backgrounds clear. So you can... Mr. Yin Yang, yo. What's up? You're back. I thought you were gonna be back tomorrow. Is it like tomorrow for you now? KMnO4 is solid. It could oxidize Cl- into chlorine gas, which could cause extra titration, leading to incorrectly high iron results. The Zimmermann reagent inhibits the side reaction. Conversion history. Conversation. Oh, I read conversion history. It's conversation history. God damn. God. No, just wanted to say get ready for what's in 1 minute. I should get ready for something you're gonna say in 1 minute? What? Did I understand that right? Did I get it right? Did I right? I'm gonna put my hair like this. Yup. So it should be already 1 minute or what? Put it like this. Oh. Guess what? Oh, what should I guess? I should guess what? Chicken butt. But I'm just kidding. Disco tomorrow. What do you mean disco tomorrow? What are these references? Laughing disco tomorrow. I don't get the reference, gang. I'm gonna type that in. What? Gift. Not gonna lie, bro. I don't get it. I don't get what you mean. Laughing disco. Oh, you don't have gifts. No. Story. I'm guessing it's sorry. Yo, don't be sorry. I don't know what this gift is, but if it's something related to money, don't. I'm sorry. I don't think a 9-year-old should spend money on the internet, especially on a fucking YouTube channel. Well, guess what? You just won 50k Roblox. Can we not double it and just give it back to the person who just gave me the 50k Robux? Cause I don't use Robux. Your final result can be reported as duck with the F. No, did you just swear? Did you just pseudo swear? Did you just fake a swearing? Whoa. Yo, we don't tolerate none of that in Correct It Dumb channel. Determining total mass of iron in a sample containing chloride ions using redox titration 45 minutes. Whoa. With potassium permanganate. Came here for 1:5 stoichiometric reaction. Since KMnO4 is not a primary standard, you must determine the exact concentration using sodium oxalate. With sodium oxalate, you must heat the solution to 75 degrees and titrate while being hot to ensure reaction proceeds quickly enough for accurate measurement. At 75 to 85 degrees Celsius to speeden as it's pretty slow. And you will not react immediately. This causes the purple color to linger in the flask, leading you to believe you have reached endpoint. False endpoint long before the true equivalence point is achieved. And titration done when the solution is hot, because otherwise it takes time for the oxalate to react with KMnO4, thus leading to false titrations. Yo, Sans fan. How we doing? Yo, I just got this. I was looking at something else. Goddamn. Yo, you're at the theme park. What type of theme park? Like water? Doing good. Oh, okay. That's cool. You're having fun right now. Oh yeah. Hell yeah. Bush D. Is that the place? Is that the place? Let me check. Bush Gardens. Okay. Oh shit. Okay. Okay. Williamsburg Amusement Park in Virginia. She. Okay. Let me see some images. Oh fuck. Hell yeah. Looks cool. Does look cool. Hmm. So you just went there with your family, or is it like a school trip? Yeah, yeah, yeah. Of course, I understand. Respect. Respect for checking out. Respect. Yep. I understand. Respect. Hell yeah. Mm-hmm. Let me go wash my face real quick. Yo, what's up? Where are you, bro? Yo, I'm still here, dog. I was out here. I was out there. I was not here for a bit. Don't worry, I'm back. I don't know if you're still here, but hey, if you're still here, holla at your boy. Ho- just, ho- just holla. This is Mr. Ginali. Oh, what's that? It's an interesting name. Interesting name. Oh, come on. You showed up on the last. Self indication of MnO4. After the equivalence point where the Mn plus 7 reacts with the oxalate to form Mn2 plus is over, and the next MnO4 added stays MnO4 minus, which at very low concentration looks like faint pink color. Tiny excess. Sodium metabisulfite. You add 3 grams of this reducing agent to ensure all iron species are converted back to bisulfite. 3 grams. Yo, somebody just used the chat. Cloudy Cook. Hi. Hello, Cloudy Cook. How you doing? 3 grams was added. Which reacts donates an electron to Fe3 plus, reducing it to Fe2 plus. Addition of Zimmermann Reinhardt reagent. I forgot what are the things in there. Mixture of MnSO4, sulfuric acid, and phosphoric acid. inhibits the side reaction uh, after titration produced is masked or forms a complex that background not affecting the pink endpoint. Let's move on to experiment number 4. Number 4. Automatic Pristin burette. Preparation and standardization of sodium thiosulfate solution. 12.5 grams of sodium thiosulfate pentahydrate was weighed and dissolved in 500 milliliters of deionized water. The solution was mixed thoroughly to obtain a homogeneous sodium thiosulfate mixture. For standardization, potassium iodide was used as a primary standard, approximately blah, 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 were weighed and dissolved in 200 milliliters of deionized water and transferred into a titration flask. Approximately 1 gram of potassium iodide was dissolved in a small amount of water and added to the potassium iodate solution. The mixture was acidified with 2 milliliters of 6 molar sulfuric acid using a graduated pipette. The liberated iodine was titrated with sodium thiosulfate solution until a pale yellow color was observed. At this point, 2 milliliters of soft solution was added using a plastic pipette, and the titration was continued until the blue color disappeared and the solution became colorless. Determination of the copper 2 ions. The 250 milliliter volumetric flask containing the copper sample was filled to the mark with the deionized water. 25 milliliter aliquot of the sample solution was transferred into an Erlenmeyer flask, and approximately 100 milliliters of deionized water was added. .250 milliliter volumetric flask containing the copper sample was filled to the mark. The solution was acidified with 2 milliliters of 6 molar sulfuric acid. Approximately 2 grams of potassium iodide was added, and the flask was immediately stampered and shaken carefully to ensure complete reaction while minimizing iodine loss. The liberated iodine was titrated with the standardized sodium thiosulfate solution. The titration was carried out until the solution turned pale yellow. Then 2 milliliters of starch solution was added, and the titration was continued until the blue color of the starch iodine complex disappeared. Solution became colorless. The procedure was repeated for 3 measurements. Oh, bro, it gives AI right away. Fuck. Fuck. I just noticed that. That gives AI right away. God damn it. This gives AI and this part. 2 milliliters of starch solution was added using plastic pipette. There is no plastic pipette. And 1 gram of potassium iodide was dissolved in a small amount of water. Really? I just added that. So, yeah. That is not looking very good. That is not proving my point of me knowing the answers. It's only 31%. What happened? Whoa, just a minute. Liberation of iodine. When you add excess potassium iodide to your acidified copper sample, the Cu2 plus ions oxidize the iodide ions. This produces a white precipitate of copper iodide and liberates molecular iodine. The copper 2 plus ions oxidize the iodide ions. This produces a white precipitate of copper iodide and liberates molecular titration with thiosulfate. The liberated iodine is then titrated with standardized sodium thiosulfate solution. The thiosulfate reduces the iodine back to iodide. You know what? Just a minute. I gotta reply to a person. Oh, what the fuck? Oh, well, what the fuck? What's this? No thanks. No thanks. Don't. Hmm. Whoa. Just forgot I was on a stream. God damn it. Liberation of iodine. This when you add excess potassium iodide to your acidified copper sample, copper ions oxidize the iodide ions. This produces a white precipitate of copper iodide and liberates molecular iodine. Titration with thiosulfate. The liberated iodine is then titrated with standardized sodium thiosulfate. Overall stoichiometry, standardization of sodium thiosulfate. Because sodium thiosulfate is not a primary standard, you first determined its exact concentration using potassium iodate. KiO3 reacts with potassium iodide in an acidic environment to release a precise amount of iodine, which is then titrated with your thiosulfate solution. Your result, you determine the mean concentration of your Na2S2O3 to be 0.10116. Determined its exact concentration using potassium iodate. Indicator stars. This experiment uses star solution as indicator. Damn, that's over. No, fuck that. Your determined mean concentration of your Na2S2O3 is to be 0.10116. The indicator, this experiment uses starch solution as the indicator, but the timing of this solution is common oral question. What does starch do? The starch turns the solution deep blue. The endpoint is reached when the deep blue disappears. You did not explain why this deep blue is forming. Didn't. How is it? Starch indicator works through a unique physical-chemical interaction rather than standard pH-based or redox-based chemical reaction based on your laboratory reports and SOPs. Here's the molecular explanation for how the starch indicator functions. Know that the specific details regarding the amylose helix and the polyiodide chains are derived from general chemical principles as they're not explicitly detailed in your provided sources. Why starch is added? Sensitivity. As you correctly noted, you wait until the solution is pale yellow because adding starch too early results in an irreversibly bound complex that would lead to a false endpoint. The purpose. The primary reason for adding starch is sensitivity. The pale yellow color of diluted iodine is very faint and difficult to distinguish by eye, especially in a solution that contains the off-white copper iodide precipitate. The result of the starch provides a much sharper visual signal, allowing you to detect even trace amounts of iodine that remain near the end point of titration. How it shows the blue color. The deep blue color is not a result of permanent chemical bond, but rather the formation of starch-iodine complex. Starch contains a component called amylose, which has a long spring-like helical molecular structure. In your flask, the liberated iodine reacts with the excess iodide to form polyiodide ions. These long chains of iodine atoms slide into the center of the amylose spring. The color, the inclusion complex, changes the way electrons move within the iodine chain, allowing complex to absorb visible light. This inclusion complex changes the way electrons move within the iodine chain, allowing the complex to absorb visible light. This is what creates the characteristic deep blue purple color. How it becomes colorless. The titration to colorless at endpoint is a direct result of redox reaction with your titrant, sodium thiosulfate, consumption of free iodine, releasing the trapped iodine, endpoint pulled out of the starch, and the reduced iodide by the thiosulfate. The blue complex can no longer exist. The solution becomes colorless, leaving behind only off-white copper iodide precipitate that formed in the first step of the experiment. Would you like to move on the complex symmetric titration of bismuth to see how the silanol orange indicator works there? Also, the summary geometric determination is a structure to help you excel in your. Shut the fuck up. Shut up. Cut your boy a little slack. Pariga dom 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 pariga. How does it sound? Pariba dom 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 pariba dom. Why do I even care? Very good question. Very good question. Wow, that is an amazing question. Why do I care? You know what? I'ma end the stream, gang. I'ma end the stream because I'm fucking. This thing is running on hopes and dreams. And I gotta give it some time to hope and dream. Peace out, YouTube. We'll be up tomorrow morning. If I don't,